solve the questions from here, then only it is like it will make sense to do higher level or something. So let's see the questions. Just a moment. So exercise 8.2, I believe you can see the screen, right?
Yes, ma'am.
The first question is a very basic question. Find the 20th and the nth term. We have already discussed questions like this. We just have to, this is in geometric progression. 20th term, nth term, you will be able to do by yourself. Now the next question, find the 12th term of a GP, where the common ratio, this is also I'm not going to discuss. Let's do third number. Okay, where it says the 5th, 8th and 11th term of a GP is this respectively. So 5th term will be AR to the power 4, right? Right, Lena?
Yes, ma'am. Yes,
That
ma'am.
is P. 8th term will be AR to the power 7. That is Q. And 11th term will be AR to the power 10. That will be S. Right, Lena?
Yes, ma'am.
Now we just have to find the relation so that Q is square is equals to PS. So Q is square means what? Q is AR to the power 7. And if you will be doing that square, like Q is this much. So if you will be doing a square over here and a square over here, what you will be getting? You will be getting A square R to the power 7 2 times 14. So this one you can break it. You can write it as AR to the power 4 into AR to the power 10. Yes or no?
Yes, ma'am.
And then you can say Q square is equals to what we wanted to prove, PS. And yes, we are getting PS. Can you see?
Yes, ma'am.
So this one was also very simple. Okay. Are you having any confusion related to this? That how we are writing AR to the power 6? Why I am saying AR to the power 4 as a fifth term? Or you understand that?
I understand.
Okay, so we are done with this one also. The fourth term of a GP is the square of the second term, and the first term is this one. Determine seventh term. When you just have to write the fourth term, you just have to write the second term, you just have to write the first term. Definitely, after solving this, all you will be getting the seventh term. Okay, so just solution you have to find. This one is also very simple. Now the next one, which term of the following sequence is this? We will be assuming that, let's say nth term, let's say the nth term is 128. So AR to the power n minus 1, that is 128. Okay, now here A value is known, R value is known, and value only we have to find from here just by solving the equation. Okay, this one also easily you will be able to do just by using the formula only. Now why I'm moving so quickly, because at last we are having a lot of questions which we will be discussing by taking time. These are the questions which you will be able to do, and I just wanted to show you. Okay, so what is the value of x if this are in GP? So you have learned one condition for GP, that is B square is equals to AC, right?
Yes, ma'am.
If you will apply that directly, you will be getting the value of x from here. Okay, now the question which I want to discuss with you is number 11. Evaluate this one, because most of the time student, whenever they see the summation sign, they end up getting confused. So here we will be having summation. This summation one I have taken because most of the time student get confused with this summation sign. No worries, whatever is given, no, we will be just expanding it, just few terms. Okay, it is given that k is equals to 1 to 11. Am I audible? Can you see the screen?
Yes, ma'am.
So if we will be expanding it, we will be getting the first term will be 2 plus 3 to the power k is there, and k value starts from 1 to 11. So the first term will be 3 to the power 1, plus the second term will be 2 plus 3 to the power 2, plus the third term will be plus. Why I'm writing plus plus plus? Because summation sign is there. Can you see summation sign is there? That means we have to add all of them, right? Third term will be 2 plus 3 to the power 3. Fourth term will be 2 plus 3 to the power 4. Fifth term will be 2 plus 3 to the power 5. Just like that, the numbers will keep on going. Till which number? 2 plus 3 to the power 11. Right, Lena?
Yes, ma'am.
Now 2 plus 2 plus 2 plus 2. This is 2. Let's just separate all the 2's. So here we are having 1 2, here we are having 1 2, here 1 2, here 1 2, here 1 2, here 1 2. So 2 2 2 2 2 2. How many times? 11 times. That we can separate it. So 2 2 2 2 2 2, 11 times we are having. So we will be having 2 into 11 plus the remaining 3 to the power 1 plus 3 to the power 2, 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus 3 to the power 4, till which number? Till 3 to the power 11. Now this is geometric series. This is in geometric progression. Can you see?
Yes, ma'am.
Here we will be using the formula for sum of n terms. The A1. What is the sum of n terms formula? Sn is equals to A r to the power n minus 1 by r minus 1, or A 1 minus r to the power n by 1 minus r. So the first formula we say when r value is greater than 1. The second formula we say when r value is less than 1. So accordingly we will be using the formula, and then we will get the sum of 11 terms of this GP. Clear?
Yes, ma'am.
So this much calculation you have to do. For the second, the bracket term, you have to use the formula. And the first term, like 2, 2, 2, 2, 2, 2, how many times? 11 times is there. So basically, 2 plus 2 plus 2, 11 times. That means 2 into 11. 22 is there in the front. Whatever we will be getting after that, we will be just doing the calculation, and that will give us our final answer. Okay. Now the next question, if you will look at it carefully, it says that the sum of first three terms of a GP, the sum of first three term of a GP is this one, and the product is this one. If you will recall the properties of GP we were discussing, I said to you that Lena, please don't take the first term as a, second term as a AR, third term as a AR square, fourth term as a AR cube, fifth term as a AR to the power 4. Please don't take it this way, otherwise it will create confusion. Here, can you see the product is 1? So if you will multiply A into AR into AR square, the first three terms, and if you will be writing the product as a 1, you will not get anything. This equation you won't be able to solve it. So rather than that, I said to you, whenever the three term is saying in the question and the product is given, please take the please assume the first three terms as A by R, and here AR. Please assume the first three term as this. This is also in GP. Okay, if you want to check, you can check it. It is also in GP, and here also the common ratio is same. So if the question is says there is a three term and the sum of that is this, product of that is this, then please assume it this way rather than this way. Okay, so if you will be taking the first term as a by R, the second term as a, and the third term is AR, then you can see here it is written that product is 1. So if you will be doing the multiplication and be writing the product, no, you can see R cancelled out, and we got A cube is equals to 1. That means A value will be 1 only. Getting it? Easily we got a value. Now the first condition
Yes.
says the sum of first three terms. Now according to the first condition, we will be writing the sum of these three. So the sum of these three will be a by r plus a plus ar, and sum of the first three term is in, that is the sum of first three term is given as a 39 by 10. We already know a value is 1, right? So we will be writing
Yes,
1
ma'am.
plus 1 plus r is equals to 39 by 10, and here we just have to find the value of r. How easily we have got the value of a, and how easily we will be getting the value of r as well. Once we will be getting a and r, then we can say find the common ratio. We can say what is common ratio. We can also find the terms. What are the terms? The terms which we have assumed: a by r, a ar. Getting it, Lena?
Yes, ma'am.
Is how we will be considering the terms. Okay, whenever the terms are given, this is how, like 3 term, 4 term, or whatever is asking, this is how we will be assuming it. Let's move ahead. The next question, question number 13 says, how many terms of GP are needed to give the sum? Okay, how many terms, let's say n terms are needed to give the sum, this one. Now you will be using the formula for n terms, that is a 1 minus r to the power n by 1 minus r. You will be just using the formula, and you will say, let's say the sum is 120. From here you have to calculate the value of n. So easily you will be able to do. Let me check the other two questions. If that is also doable, I'm going to leave that for you. We will be discussing the part which is not, like, which we actually need to discuss together. The sum of first three term, the sum of next three term, determine the first term, and the common ratio. Yeah, number 14 also you try it, you will be able to do it. And number 15 also, as I can see, it is very simple. Let's move ahead. These are the questions which we wanted, like which we need to discuss together. So the first question says, find a GP. Let me stretch it a bit. Okay, so here the first number 16 says, find a GP for which the sum of first two term is given, and the fifth term is fourth times the third term. The fourth, 10th and 16th term, find the. Okay, these two are just like you will be writing the terms, you will be writing the sum, and you will be getting the values. Okay, number 18 is what we are going to discuss. We have to find the sum of this, this, this till infinity. Is it in GP, Lina?
No, ma'am.
It's not in GP. So first thing, we are doing geometric progression. So we are doing geometric progression. So obviously we need to make it in, like easily we can make it in GP, even if you are not doing geometric progression. If this question came in the exam, how you will identify? So we can convert it to geometric series. How? We can take out 8 common. So we will be having 1 plus 11 plus 111 plus 1111 plus dot dot dot. Yes or no?
Yes, ma'am.
Now, if we will be multiplying and dividing it by 9, we will be having 8 by 9, and I am going to multiply by 9 also. So that 9 which I am going to multiply, that I am going to introduce in the bracket. So we will be having 9 plus 99 plus 999 plus 9999 plus dot dot dot. Is it clear so far?
Yes, ma'am.
So we will be having 8 by 9 here the first term 9, we can write it as a 10 minus 1. The second term 99, we can write 10 square minus 1. The third term 999, we can write 1000 minus 1, 10 cube minus 1. We can write it as a 10 cube minus 1. The fourth term, we can write it as a 10 to the power 4 minus 1. Just like that, we will be having the sequence. Now, 1, 1, 1, 1, 1, 1 is there. It's completely fine. This 10, 10 square, 10 cube, 10 to the power 4. This one is in GP, right?
Yes, ma'am.
Just a second. Okay. So here now we can use the formula of GP, that is 8 by 9, and this one we are having 10 plus 10 square plus 10 cube plus 10 to the power 4 plus dot dot dot. Here one thing you can notice in the question itself, it says find the sum of n terms. N terms sum we have to find from here. So we will be taking till n terms. Okay. That means 10, 10 square, 10 to the power 3, 10 to the power 4, 10 to the power n minus 1 will be the last term. Okay. Similarly, minus 1, minus 1, minus 1, minus 1, minus 1, minus 1 till how long it will go? It will go till n, right? So minus 1, 1, 1, 1, 1, 1, 1, 1 we will be having. So can I write directly minus n? Are you getting it, or shall I show you with the like proper expansion? I'm talking this negative 1, this negative 1, this negative 1, this negative 1 till n times we are having negative 1, negative 1, negative 1, negative 1. So can I say it will be minus n?
Yes, ma'am.
Okay, so for this one is in geometric series. This one is geometric progression. As you can see, it's a geometric sequence. We can just add the number of term by using the formula Sn is equals to a 1 minus r to the power n by 1 minus r, or the other formula, the r to the power n minus 1 by r minus 1. Just use the formula according to the common ratio, and then you will be getting this sum. This part 8 by 9 is outside, it's totally fine. Minus n is after that, it's totally fine. We just have to do the calculation after that, and the answer definitely will be in terms of n only. Clearly now?
Yes, ma'am.
Okay, let's move ahead. The next part says find the sum of the product. Number 19 we are doing, and the question says find the sum of product of the corresponding term of sequence. Here we are having the sequence. First sequence is 2, 4, 8, 16, 32. Okay, this is one of the sequence, and one more sequence is given as 128, 32, 8, 2, 1 by 2. What the question says, find the sum of product of corresponding term. That means we will be finding the product of this two. We will be finding the product of this two. Product of corresponding term. Product of this two. Product of this two. Product of this two. We will be finding the product of corresponding term, and then we will be adding all of them. Find the sum of product of corresponding term. So product of corresponding term, that means 2 into 128. Product of corresponding term is 4 into 32. Product of corresponding term is 8 into 8. Product of corresponding term is 16 into 2. And product of corresponding term is 32 into 1 by 2. These are the product of corresponding term of the given sequences. Now what we have to find? We have to find the sum of these. The sum of all this. Are you getting it?
Yes, ma'am.
Now, what we will be doing, we will be multiplying it. So, 128 into 2, it will be 8 2 times 66, carry 1 to 2 times 4, 5 to 1, 256 plus 32 into 4, 4 2 times 8, 4 3 times 12, 128 plus 64 plus 32 plus 16. Now if you can see from the last, it is in GP. 16 2 times 32, 32 2 times 64, 64 2 times 128, 128 2 times 256. It's in GP. Can you see?
Yes, ma'am.
So if it's in GP, then we can use the formula of GP. That is A r to the power n minus 1 by r minus 1. We can find the sum of this. How many terms? 1, 2, 3, 4, 5 terms. Clear?
Yes.
Let's move ahead. So here the only trick was to identify. Two sequences are there. Randomly, if you will look at the question, you will feel like one sequence is there. If you will not read the word and. Okay. Now the product of sum, this word is also, this word can confuse you. So please be careful. Product of the corresponding term, and then their sum we have to find. Now the next one is talking about show that the product of the corresponding term of the sequence this and this form a GP. So we have to show that if we are having one of the sequence as this one and another sequence as this one, then here also it says show that product of the corresponding term. If we will be finding the product of corresponding term, first term became this, second term became AA, like AR and AR. So this AR with that AR. The third term became AR square with AR square. The fourth term became just like this. The last term became AR to the power n minus 1 into AR to the power n minus 1. Is it in GP? So if you will look at the pattern, yes, it's in GP only. If you will arrange it a bit more, you can say the first term is AA, the second term is AA with RR, the third term is AA with RR square, the fourth term will be AA with RR cube. So obviously you can see it's in GP only. Can you see?
Yes, ma'am.
It looks like AR square, AR cube, just like that. And the last term will be AR to the power n minus 1. So yes, it's in GP. We can, if the question will be asking, show the, find the common ratio. Okay, it's asking only find the common ratio. So we can find the common ratio easily by taking the second term divided by the first term. And we can say this is the common ratio. Okay. So we are done with this one also. Now the next question says find four number forming a geometric progression in which the third term is greater than the first term by 9 and second term is greater than the fourth term by 18. Okay. Have you solved all these questions by yourself?
No, ma'am.
That's what like I thought to first solve it, because you are doing high, we are discussing higher level questions, JEE level questions. So before that you need to do this question. Not only this only, Lena, you also need to do questions from the miscellaneous exercise, questions from the examples, like each and every question from NCRT. Once you are done with that, then only if you are doing extra question, that will make sense. Okay, so here the number 21 question says, yeah, find four number forming a geometric progression. So if we are saying A, B, C, D are in GP, okay, the first term we are taking A, the second term AR, third term AR square, and fourth term AR cube. These are the four term we are taking a GP, in which third, what is written? Seam. Third term, okay. Third term is greater than the first term by 9. Third term is greater than the first term by 9. So if third term is already greater, then we need to add 9 to first term. Right, Lena?
Yes, ma'am.
Similarly, it says that the second term is greater than fourth term by 18. So second term is greater than fourth term. Second term is already greater. So fourth term by 18. These two equations we are having. And we just have to solve these two equations for the value of A and B. Yeah. Find the four numbers. For the value of A and common ratio, we have to solve it. Let's see how can we solve it. So here we will be taking out A common. So we will be having R square minus 1 is equals to 9. Or we can also say that A 1 minus R square is equals to 9. Here what we'll be having, if we'll be taking AR common, so we will be having 1 minus R square is equals to 18. Can you see? We can just substitute this A 1 minus R square value is negative 9 over there. Negative 9.
Yes, ma'am.
We can just substitute negative 9 over here. R will be remaining because A 1 minus R square value is negative 9 is equals to 18, and R we got. Once we got R, we can use any of the equation to get the value of A. Okay, it's that simple. Whatever is written in the question, you write it on your paper. Okay, in the of obviously in mathematical form. Whatever here the sentence will be written, and there you write the geometric progression, the geometric series, the n term, the third term, fourth term, fifth term, nth term, greater than, less than. You will be getting equation. Now your job is to just solve the equation. Okay, so we are done with this one also. Now the next says, if the pth, qth, rth term of ABC are this, prove that this. Pth, qth, rth term, if you have to assume, then you can take the geometric sequence as a, the first term as a, the common ratio as a R, capital R, please take. This question we have already discussed, still I am reminding you, try it by yourself and do let me know. First term, like one of the term is A, the second term, instead of taking AR, the small r, I am taking capital R. Okay, here also I am taking capital R. Here AR square, here AR cube. How many terms we have to take? The pth term, qth term, rth term. Okay, so the pth term will be, nth term is AR to the power n minus 1. So pth term, can I write AR to the power p minus 1? Can I?
Yes, ma'am.
Is equals to E. One of the equation. It is given that Pth term is A, Qth term is B, Rth term is C. So that's why I have written R capital. So with that, I have also taken A capital, so that it will not create confusion with the small a, capital A. Now Qth term is given as a R to the power Q minus 1 is also given as a B. A R to the power Rth term R minus 1 will also given as a C. Now these three equations we are having, and we have to prove something. That is what we have to prove. Let me write it if you can't see. It is written over there that A to the power Q minus R, this into B to the power R minus P, this into c to the power p minus q is equals to 1, we have to prove. So a to the power q minus r is there, no? What you will be doing, a value you will be putting over here. You are going to substitute a value over here. This a value you are going to substitute at the place of a, this total. Similarly, b value you are going to substitute at the place of b. Now you have to definitely do the apply the properties of exponent, and then you have to simplify it. Once you will be simplifying the left hand side, you will end up getting 1 as an answer. Are you getting, Lena?
Yes, ma'am.
Okay, please do try this question. Just sit and solve each and every question and do let me know whether you have done it or not. And if any confusion, if you encounter any problem which is not solvable, which is confusing, please let me know. I'll be taking those questions in the class. So we are done with this one also. If the first and the nth term of the GP, if the first and the nth term of the GP are A and B, and if P is the product of n term, prove that this is. So first term is A, nth term. Okay, let's say first term is capital A. Again, A and B is given, which will create confusion if you will take first term as a A. The nth term formula is A r to the power n minus 1. So A is A and A r to the power n minus 1 is B. This two equation is already given in the question. And if P is the product of n term, okay, P is the product of n term, that means P is A, AR, AR square, AR to the power 3, dot dot dot, AR to the power n minus 1. Okay, so this is how P is the product of n term. We have to prove that P square is equals to AB to the power n. Let's check it. Are we going to get P square is equals to? Okay, let's multiply each first. This product P, can we simplify it a bit more before moving ahead with P square? So if we will be simplifying it a bit more, A, A, A. How many times A? N times. So can I say A to the power N? Lena, A into A into A into A into N. How many times? N times. Can I say it will be A to the power N?
Yes, ma'am.
And after that we are having R into R square into R cube into R to the power 4 into R to the power 5 into R to the power 6 into R to the power n minus 1. So this one, can we use this formula that R to the power 1 plus 2 plus 3 plus 4 plus 5 n minus 1, which can be written as sum of n natural number formula is sum of n natural number formula is n into n plus 1 by 2. So here we are having, here instead of n we are having n minus 1. So we will be using the same formula. Okay, the same formula I am going to write and write it in this form. N into n plus 1 by 2. Our n is n minus 1. N plus 1, that is n plus 1 by 2. Is it clear?
Yes, ma'am.
If we will simplify it a bit more, it will be r to the power n minus 1 into n by 2. So basically we ended up getting a to the power n into r to the power n into n minus 1 by 2. Okay, that is P. We have to prove something related to P square. Okay, which question we were doing? Can you see P square is there? Can you see?
Yes, ma'am.
P square is there. Let's find P square. P square means a to the power 2n, right? And r here also we will be doing a square of both the term will be doing, yes or no?
Yes, ma'am.
So we will be having n into n minus 1. Now let's check, is it ab to the power something? So a is a only and b is ar to the power n minus 1. So this is, we are having, let me write it over here. A is a and b is ar to the power n minus 1. Yeah. So we have to write ab to the power, ab to the power n. We have to prove it. Let's check what is ab to the power n. If we will be getting the same as a p square, then we can say that p square value also we got this one, ab to the power n value also we got this one, hence both are same. So rather than just doing the arrangement, I am doing a straightforward way, that is ab to the power n means for me it is a into a r to the power n minus 1, and that is total power n. Okay, is it only n or what? Yeah, it's only n. Let me check. So here we will be having a square r to the power n minus 1, that is power n. So we will be having a to the power 2n and r to the power n into n minus 1. Yes or no? Lena,
Yes, ma'am.
is it p square value was same? Can you see?
Yes, ma'am.
We are done, right?
Yes, ma'am.
So easily this way you will be able to do, rather than doing the arrangement. We have checked whether the right hand side also coming this one or not. Okay. Yes, right hand side is coming this one only, and we are done with that. So do try all this question and do let me know. Okay. Let's move ahead with the next question. The next question says, show that the ratio of sum of first and term of a GP to the sum of terms from n plus 1 n. What exactly is written? Let me check the question. Okay. It's written like this. Let's show that the sum of first and term of the GP. First and term of the GP to the sum of first and terms and the sum of terms from n plus 1 nth term to nth term. That ratio is 1 by r to the power n. Okay, this is what we have to prove. It is 1 by r to the power n. Show that the sum of first n term to the sum of terms from n plus 1 to 2n term, the sum of that and the sum of this ratio will be 1 by r to the power n. That's what we have to prove. All right. So the what is the formula for sum of n terms? Can we write it a sum of n terms as ar square plus dot 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 ar to the power n minus 1? That sum, this is the sum of n terms. Can we?
Yes, ma'am.
And what about the sum of n plus 1th term to 2nth term? So sum of n plus 1th term will be a r to the power n. Right, Lena? N plus 1th term will be 1 less than that.
Yes, ma'am.
The next term will be ar to the power n plus 1. Then the next term will be ar to the power n plus 2. Then the next term will be ar to the power n plus 3. Till how much? Like what will be the last term? 2n. That means ar to the power 2n minus 1. Till that term, we have to find the sum, right, Lena?
Yes, ma'am.
Now the ratio between these two. If we will be taking common r over the ratio between that one and this one, if we will be taking what can we say? If we will be taking r common over here, r common over here, can we write it as a plus ar plus ar square plus ar to the power 3 plus dot 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 ar we have taken common, one r we have taken common, so it will be ar to the power n minus 1, if from ar to the power 2n minus 1, if we will be taking r common out. Okay, we can write it as ar to the power n plus n minus 1. So yeah, here we will be taking r common, or there we will be doing something. Let me check. Okay, instead of r, here we'll be taking r to the power n common. Now, are you able to relate with it? R to the power n I have taken common. So from here, 1 is remaining, 1 r. From here, only 2 is remaining, only 3 is remaining. And from the last one, ar to the power n minus 1 will be remaining. Can you see it, Lina?
Yes, ma'am.
Why we are doing so? So that we can reach to the proof. 1 by r to the power n. So now, whatever is in bracket, that is exactly our equation number 1, right?
Yes, ma'am.
So ar square, ar to the power n minus 1. Sum of, if we will be finding the ratio, we will be getting ar, ar square, ar to the power 3 plus ar to the power n minus 1. And in the denominator, if we have taken r to the power n common out, then we will be having ar, ar square, ar cube plus ar to the power n minus 1. Now this and this will cancel out each other. Can you see?
Yes, ma'am.
Now we'll be having is equals to 1 by r to the power n as a ratio, and that's what we wanted to prove over here. Is it clear?
Yes, ma'am.
Okay, now let me have some water. Give me a minute, okay? If you want to note it down, I'm just keeping the screen as it is. Please note it down.
Okay, ma'am.
Yeah, let's continue. So what the next question says, let me check. So the next question says A, B, C, D are in GP so that this is equals to that. If A, B, C, D are in GP, then we can keep A as a A. But B, since it's in GP, we can take by ourselves that the other term, the next term will be AR, the next term will be AR square, the next term will be AR cube, right, Lena? If A, B, C, D are in GP, we can take, okay, first term is A, second term is AR, third term is AR square, and the fourth term is AR cube. Can we take it like this?
Yes, ma'am.
Now we have to prove something that A square plus B square plus C square in bracket B square plus C square plus D square. This product is equals to AB plus BC plus CD whole square. This. So we will be solving the left hand side by substituting the value of B, C, D, everything. We will be whatever expression we will be getting, we'll be keeping it aside. Then we will be solving the right hand side, and then in the right hand side also we will put the value of BCD and we will try to solve it. Eventually you will see whatever you have got from the left hand side, right hand side is also giving the same, and then you can say left hand side is equals to right hand side. Okay. Okay, Lina,
Yes, ma'am.
will you be able to do that?
Yes, ma'am.
Here a bit of calculation you have to do. Okay, and if it is possible to take out common r or something, please do that. You will be able to do that. Now the next question says that if insert two number in between 3 and 81. So 3, 81, and we are saying the second number is G1, third number is G2. We have inserted two number in between 3 and 81 so that the resulting sequence is in GP. Now we have to show that the resulting sequence is in GP. Okay. So if the resulting sequence is in GP, okay, the next term we can take it as the first term we know and the last term 1, 2, 3, 4. Fourth term we know. So we can say A is 3 over here, and fourth term formula for the fourth term formula is AR to the power n minus 1. That means 3. So we know AR cube is equals to 81. So A value we already know as a 3 into R cube is equals to 81. So we will be getting R cube as a 27, which will give R value as a 3. Is it clear so far?
Yes, ma'am.
So insert two number. We have inserted two number G1, G2. We don't know what to take at that place. But we ended up getting, we can realize, like we can note it down from here that the first term is 3 and the last term is also given, or we can say the fourth term is also given. From there we are getting the R value. Once we know A, once we know R, it is very simple to introduce two numbers over here. We can write the sequence A, AR, AR square, AR to the power 3. AR to the power 3, A we already know. AR, we can say AR will be 3 into 3. AR square will be 3 into 3 square. AR cube already we know. We just have to focus on this two number. This will be 9. 9 3 times 27. Can you see?
Yes, ma'am.
Is it clear?
Yes, ma'am.
Let's move ahead. What the next question says, find the value of n. We are done till here. Find the value of n so that a to the power n plus 1 plus b to the power n plus 1 by an plus bn may be the geometric mean between a and b. It is the geometric mean. What is the meaning of geometric mean? We say if a, b, c are in GP, then b is the geometric mean, right? And b square is equals to ac. That's what we write. Right, Lena?
Yes, ma'am.
That is the meaning of geometric mean, right? That the
Yes,
value
ma'am.
of b will be root ac. This is what geometric mean means. Okay, so here it says, here in our question it says that, just read it carefully. Okay, it says that find the value of n. Okay, we will be finding the value of n so that this is the geometric mean. Okay, if it is the geometric mean, then we can write it as, can we write this is equals to, it is geometric mean between A and B. A and B is there, the first term and the next term. So can we write the middle term, that is A to the power n plus 1 plus B to the power n plus 1 divided by A to the power n plus B to the power n is equals to under root AB. Can we write, Lena? Since it is a geometric mean, B square is equals to AC and B is equals to root AC.
Yes, ma'am.
This is our B. And this is A, this is, let's say, C. Okay, so accordingly we are using the formulas. All right, now we have to solve it for finding the value of n. Let's solve it. Okay, so we are having a to the power n plus 1 plus b to the power n plus 1 is equals to root ab. I can write it as ab to the power 1 by 2 and crisscross multiplication a to the power n plus b to the power n. Here the calculation will be a bit longer, but eventually, hopefully, we will be getting the value of n from here. So a to the power n plus 1 plus b to the power n plus 1 is equals to, if we will be doing distributive property, it will be a to the power n is already there. 1 by 2, if we will be multiplying, it will be n plus 1 by 2. Are you getting it? The first term plus a to the power 1 by 2 and b to the power n plus 1 by 2. Are you getting it, Lena?
Yes, ma'am.
Now a we are going to keep on one side and b we are going to keep on another side. Let's see what exactly are we getting. Are we getting anything out of it? B to the power n plus 1 minus a to the power 1 by 2 times b to the power n plus 1 by 2 is equals to 0. Okay, we have taken everything on one side. Let's see. A to the power n we can take out common plus 1 by 2 we can take common. Okay, the first term what will be remaining? A to the power 1 by 2 will be remaining. Are you getting it? Because n plus 1 we can write it as a to the power n plus 1. This one can be written as a to the power n plus 1 by 2 plus 1 by 2. Right, Lena?
Yes, ma'am.
So a to the power n plus 1 by 2 we can take out as a common from this two term. What will be remaining? A to the power 1 by 2 from the first term minus b to the power 1 by 2 from the second term. Similarly, b to the power n plus 1 by 2 we can take out as a common and we will be having b to the power 1 by 2 minus a to the power 1 by 2. So we want to keep both the brackets same the way we do in factorization. So we can take out negative common out from here. And it will be a to the power 1 by 2 minus b to the power 1 by 2. Are you getting it? Let me know if any confusion. is equals to 0. Okay. So we can say one of the bracket is a to the power n plus 1 by 2 minus b to the power n plus 1 by 2, and another bracket is a to the power 1 by 2 minus b to the power 1 by 2. That is 0. Okay. So if we get such term, what we do, either this one is 0 or that one is 0. Whenever we get x minus 3, x minus 4 is equals to 0, what we say, either x minus 3 is 0, which implies x equals to 3, or x minus 4 is 0, which implies x equals to 4. So similarly, if here we will be doing, so this one I am going to leave because n is not there, and we wanna, our total focus is on finding the value of n. So if we will be taking this one, a to the power n plus 1 by 2 minus b to the power n plus 1 by 2 is equals to 0. That means a to the power n plus 1 by 2 is equals to b to the power n plus 1 by 2. A by b to the power, a by b to the power n plus 1 by 2 is equals to 1, not 0, because you are pulling that b and you are keeping it in the denominator. If you will subtract it, then 0 will be remaining over there. Since you are taking that, suppose 1 is there multiplied with that, okay, you are taking it in the denominator. That means 1 is remaining over there, right, Lina?
Yes, ma'am.
If you will be subtracting this b to the power n plus 1 by 2, then 1 will also come with that b, and there 0 will be remaining. But since we are talking about multiplication and division, we are taking that b to the power n by 2 in the denominator. That's why 1 will be remaining over there. So we will be getting a by b to the power n plus 1 by 2, and 1 on the other side. Can we write a by b to the power 0?
Yes, ma'am.
Okay. So we can take n, now comparing the powers, we can get n plus 1 by 2 is 0. So n value is negative 1 by 2. Got it?
Yes, ma'am.
Clear?
Yes, ma'am.
Let's move ahead. Okay, so we are done with 27. Now 28 says the sum of two numbers is 6 times their geometric mean. The sum of two numbers is 6 times their geometric mean. So that number are in ratio this and this. Okay, let's say the numbers are A, B. Their geometric mean will be root AB. Okay. Now the sum of two numbers. The sum of two numbers. Can I rub this part? Whatever we have done.
Yes,
Okay.
ma'am.
Let's do it down. So the question says the sum of two numbers are 6 times their geometric mean. Sum of two numbers 6 times their geometric mean. This is what the question says. Okay. According to question, we are getting this condition. If we will be squaring, whenever there is a square root, what we do? We do squaring both sides. So we will be having a plus b whole square is equals to 36ab. Right, Lena?
Yes, ma'am.
Okay. So this is one of the equation we are having. If we will try to solve it, what will be getting a square plus 2ab plus b square is equals to 36ab. Okay, let's keep it as it is. If we feel the need of solving it, we will be solving it. Now we know a formula that a minus b whole square is equals to a plus b whole square plus 2ab minus 4ab. Do you know this formula, Lina?
Yes, ma'am.
So from here, a minus b whole square, can I say a plus b whole square means 36ab minus 4ab. So a minus b whole square will be 36 minus 4, 5, 6, 32. 32ab, right, Lena?
Yes, ma'am.
Okay. So a plus b whole square we are having in hand, this much. This one, this information we are having in hand, or this one we are having in hand. And from here we can write a minus b will be root 32 ab, right Lena?
Yes, ma'am.
Plus minus. So root 32 ab will be root 32 to the power 5. That means 4 root 2 2ab. Okay. Now if we will solve a plus b and a minus b, let's see what we are getting. What we need to find over here, the sum of two terms is 6 times their geometric mean, so that numbers are in ratio. We have to show that a is to b is in ratio whatever is given. So basically we have to find a, we have to find b. Let's find a. 2a is equals to, okay, this one if we will add it, what will be getting? 6 root ab plus 4 root 2ab. 2a is a will be root ab we can take out common, plus 6 plus 4 root 2 divided by 2. Is it clear?
Yes, ma'am.
Root ab, and if we will be taking out 2 common from the numerator, will be 3 plus 2 root 2. Right, Lena?
Yes, ma'am.
Now b value. B value will be from equation number 1, 6 root ab minus a value. So a value is root ab 3 plus 2 root 2. If from here also you can see two terms are there, the first term and the second term. If from here also we will be taking out root ab common, let's see what are we going to get. So if we will be taking out root ab common, we will be getting 6 from here minus 3 plus 2 root 2. So minus 3 minus 2 root 2. Is it okay?
Yes, ma'am.
So we will be having root ab over here. 6 minus 3 is 3 only, and minus 2 root 2. This is the value of b. What we wanted to find, a is to b, according to us we are getting a is to b. A value is root ab 3 plus 2 root 2, and b value is root ab 3 minus 2 root 2. A B can cancel out each other. So a is to b 3 plus 2 root 2, 3 minus 2 root 2. That's what we are getting. Can you say that's what we wanted to prove over here? Can you see, Lena?
Yes, ma'am.
Is it clear? Let's summarize the whole
Yes,
thing,
ma'am.
what we did. Here the question says that sum of two numbers is 6 times their geometric mean. Sum of two number, if I am taking one of the number as a, another number as a b. So sum of this a and b is 6 times their geometric mean. What will be the geometric mean? Root ab. Okay. So geometric means the product of these two inside the root sign, and that's what we have learned while taking the concept of a b c are in ap, then b square is equals to ac and b will be root ac. So from there only we have got that a sum of this two term, that is a plus b is equals to 6 times root ab. Now we have just done the squaring and we have kept it aside to check whether how we'll be using this information. Now we know one formula, that is a minus b whole square is equals to a plus b whole square minus 4ab. In that formula we have taken this value and we have used that. Now we know a plus b, we know a minus b, we can solve the equation, we can get the value of a and b. That's it. Clear?
Yes, ma'am.
Let's move ahead. So the next question says, if A and G are AM and GM respectively between two positive number, prove that this. Okay. So A and G are AM and GM. Let's do over here. A and G are AM and GM in between two numbers, let's say A and B. So if A is the AM arithmetic mean, what is the formula for arithmetic mean? Whatever is sitting in the middle, that will be sum of A plus B by 2. Can I write? Because if A, B, C are in AP, then B is equals to A plus C by 2. Yes or no, Lina?
Yes, ma'am.
So we can write arithmetic means arithmetic mean means sum of the left side right side divided by 2. That is AM. And what is GM? Geometric mean means if AB is there, so geometric mean will be root AB. Right, Lena?
Yes, ma'am.
So A is the arithmetic mean and G is the geometric mean. We will be representing A plus B by 2 as a and root AB as a G. Now what does the question says? If A and G are AM and GM respectively between two number, then we have to prove this. So we know we know over here what we know. We know A plus B is 2A from equation number 1, and we also know AB is G square from equation number 2. Right, Lena? This much information we are having
Yes,
and
ma'am.
this 2 we got from the rectangular box, right?
Yes, ma'am.
Now again we are going to use the same formula, that is A minus B whole square is equals to A plus B whole square minus 4AB. Okay, A plus B is 2A whole square minus 4AB means 4 into G square. So we will be having 2A square minus 4G square. Is it clear so far?
Yes, ma'am.
Now we have to find the numbers A and B. Just that. How? By using A plus B and A minus B expression. Okay. So let's do that. So A plus B we are having in hand 2A, and A minus B we are having in hand A minus B square, we are having this one. A minus B will be under root that. Okay. So under root I am going to write 2A square minus 4G square. Now we have to solve it for A and B. Okay. Let's solve it. We will be having 2A is equals to 2A plus 2A square minus 4G square. A is equals to 2A plus root 2A square minus 4G square divided by 2. Now 2 and 2 we can cancel out. So A value we will be getting A plus root, okay, plus minus we have to take because there we have taken a square root. This one will be plus minus plus minus plus minus plus minus 2 2 if we will take out, okay, 2 taking out 2 common is not possible. No. What we wanted to find? Are we missing anything? Let's check. Oh yeah, can you see? Can you see here I have not taken the square properly?
Yes, ma'am.
It will be 4A square, right?
Yes, ma'am.
And eventually 2 will come out from the square root sign. So it will be not 2A square, it will be 4A square. So 2 will come out. Okay, so 2 will come out, denominator will cancel out that 2. We will be having a square minus g square only in this. This is our a value. Now we will be finding b value. Okay, and we will be checking whether we have proved that this number is coming on it. And you will find that this number will only come, Lena. Okay, so this is what we have got. Like, are you going to solve it for plus sign and minus sign? Please don't do. Just solve it for plus sign. Okay, just solve it for plus
Okay,
sign.
ma'am.
B value you will be getting the same thing with negative, and just the vice versa you will be getting. So just solve for plus 1. This is what you are going to get eventually. Okay, are you getting it, Lena?
Yes, ma'am.
I am saying just solve by taking a value as a plus under root a square minus g square. Now b value you will be getting a minus under root a square minus g square. If you will be solving by taking a value as a minus under root a square minus g square, then b value you will be getting a plus. So just reciprocal you will be getting. Okay, let me write what I am talking about. I am saying that a you got a plus minus under root a square minus g square. Now if you will be solving by taking a is equals to a plus root a square minus g square, then b value definitely you will get a minus root a square minus g square. And if you will be solving by taking a is equals to a minus root a square minus g square, then definitely b value you will be getting a plus root a square minus g square. So eventually you will say that both the value of a and b are a plus minus under root a square minus g square. Check it. Prove that the numbers are this. Can you see?
Yes, ma'am.
So a square minus g square means what? A plus g, a minus g only, right?
Yes, ma'am.
Now the next one. The number of bacteria in a